Ever find yourself like watching a huge piece of machinery at work? Maybe in a factory or something.
Yeah.
It's kind of mesmerizing, but it also makes you think, how on earth do they keep everything safe around all that power, you know?
Totally.
If you're anything like us, you just want to understand how things work, especially when it comes to something as important as safety.
Couldn't agree more. And that's exactly what we're diving into today. Machine guarding solutions. We've been poring over this incredibly detailed resource by PowerSafe Automation. They've got it all laid out, all these different ways to make sure people are safe around industrial machinery.
It is really impressive, the range of solutions they cover. And we're not just skimming the surface here. We're going deep. We're going to break down the types of guards, yeah. But the really interesting part is the thinking behind them. Like, why do they work this way? How are they designed?
Exactly. It's about understanding the principles.
Right, the principles at play. Our goal is to leave you with this, really clear understanding of a vital part of industrial safety without getting bogged down in super technical language.
I'm going to keep it practical.
Yeah, absolutely. And one thing that really stood out to me from the source material is the focus on a comprehensive approach to safety. It's not just about protecting the person operating the machine. It's about everyone in the vicinity.
Yeah. Everyone who might be exposed.
That's a big deal. So let's jump right in. I think a lot of companies struggle with this, right? They have all this existing equipment, older machines. What do they call those? Legacy machines.
Legacy machines.
Trying to bring those up to modern safety standards without impacting production can feel like a really daunting task.
I can imagine. It's a tricky balance for sure.
It is. And this is where the source material brings up this concept of safety 360. And they really emphasize how important this is when you're trying to improve safety on those legacy machines.
Safety 360, it's more than just a checklist, right? It's a philosophy.
It is.
It's a way of thinking about safety. Like, you're not just bolting on a guard here and there. You're looking at the whole picture, the entire lifespan of the equipment, from design to decommissioning.
That makes a lot of sense. It's about being proactive.
Right. Proactive, not reactive.
And adaptable, right? Because, technology changes, processes evolve.
Exactly. You have to be willing to adapt, to come up with new strategies. And that's really the key to achieving real, lasting improvements in workplace safety, especially when you're dealing with machines that have been around for a while.
Makes sense. You can't just put a Band-Aid on a bigger problem.
Right. It needs to be a holistic approach, integrated.
Exactly. All right, so let's talk about something a bit more tangible. Modular machine enclosures. They seem like kind of foundational to machine guarding, don't they?
They are. Yeah, they're like the building blocks. Think of them as like custom-built protective boxes, specifically designed for the dangerous parts of a machine, the points of operation, as they're called.
Right. And the source even cites the OSHA standard for that, which is 1910.212A3, for anyone who wants to look that up.
It's all there, black and white.
It is. And it's really interesting how these modular enclosures are put together. They use this modular T-slotted extrusion framing. It's like, imagine really strong, super adaptable metal building blocks that you can configure in all sorts of ways.
It's like an industrial-grade Lego set almost.
Exactly. And then onto this framework, they attach panels, often made from wire mesh so you can see what's going on inside, or polycarbonate, which is like this super tough, clear plastic. And of course, you need access, right? So they've got doors built in and all the necessary hardware to hold it all together.
It's all designed to be really robust.
It has to be. So you have this physical barrier, but the use of wire mesh or clear panels means operators aren't working blind. They can still see what's happening. And I'm guessing the access doors aren't just for convenience. There's more to it, right?
Oh, yeah. There's a lot more to it than that. They integrate these safety interlock switches. So if someone opens a door while the machine is running, the switch immediately cuts the power.
Oh, wow.
So that prevents anyone from getting hurt.
Yeah.
It's like this combination of solid physical barrier and then these smart safety features.
Yeah.
That's what makes modular enclosures so effective.
Yeah, I can see that. So, okay, next up, vertical safety doors. The source material mentions that these are great for saving space, which is, you can imagine on a busy factory floor, that's a huge benefit.
Oh, absolutely. Space is always at a premium.
Yeah.
And their main job is to prevent pinch points. Those areas where someone could get a body part, caught or crushed. Really nasty injuries.
Yeah, not good. Not good at all.
No. And the way these doors work, it's actually quite interesting. They use a double-acting cylinder, which is powered by directional control valves. These valves regulate the flow of air or hydraulics fluid. And to prevent the door from, just slamming shut because of gravity. They have a special component called a PO check valve. PO stands for pilot operated. It's like a one-way valve that specifically prevents the door from falling if there's a loss of power.
So it's like an extra safety net.
Yeah, exactly. A backup system.
I like that. And it also mentions two-hand controls with an anti-tie down safety relay. What's the point of that?
Oh, that's critical for operator safety.
Yeah.
So the two-hand control means you have to use both hands to start the machine, keeps your hands out of the danger zone.
Yeah.
And the anti-tie down part of the relay prevents you from, cheating the system by just taping one of the buttons down.
Oh, clever.
It forces you to keep both hands away from the dangerous area while the door is closing or the machine is starting up.
Got it. So it's really about making sure the operator is fully engaged in the safety process.
Exactly. No shortcuts.
And it looks like you can actually add even more safety features to these vertical doors if needed.
You can. They talk about things like rod locks for extra security to keep the door in place, proximity sensors that can detect if someone's getting too close to the door as it's moving, and even safety valves as like a final layer of protection in case something goes wrong with the pneumatic or hydraulic system.
Okay. So these are really adaptable.
Very much so. You can customize them to meet the specific needs of the application.
All right, moving on to perimeter safety guards. These sound like they're used to protect larger areas, like, I don't know, around robots or entire production lines.
Mm-hmm. You got it. They're like multi-sided barriers to keep workers separated from the hazardous zones. The source specifically mentions robotic work cells, and they even reference the OSHA standard for robot safety, which is R15.06.
Yeah.
But they're not just for robots. They're also widely used for general access control around production lines and other automated equipment.
And it seems like there's a lot of thought that goes into how these perimeter guards are designed.
Oh yeah, tons. They're engineered with very specific heights and what they call sweeps, which is like the gap between the floor and the bottom of the guard.
Right.
So that people can't just, reach under or over it.
Right.
They usually use OSHA compliant black wire mesh with very specific opening sizes.
To prevent people from reaching through, right.
Exactly.
Yeah.
The posts are often painted like a bright yellow.
So they're highly visible.
High visibility, yeah. And they include, operator doors or PIT doors. PIT stands for personnel access, so that workers can safely enter the guarded area. And of course, these doors have, handles, hinges, all the necessary stuff. And they often include things like cable trays to manage all the wiring, cut kits for making adjustments on site, and ways to securely attach them to walking surfaces, which actually ties back to another OSHA standard, 1910.212B, which is all about guarding floor openings and platforms.
So it's a whole system, really. It's not just a fence.
Exactly. It's all interconnected.
And I see they can be enhanced with some pretty high-tech stuff.
Oh yeah, for sure. For areas where you can't have a fixed barrier or where there might be blind spots, you can integrate presence sensing devices. Things like safety laser scanners or 3D safety radars.
That's cool.
Yeah. They can detect if someone enters a dangerous area, and they'll trigger the machine to stop automatically, which is especially important for, robotic systems where you have these very stringent safety requirements.
Right. Okay, let's talk about some really heavy-duty stuff. Stamping and punch press guards. I mean, these machines they're incredibly powerful. So the guarding has to be, next level.
Yeah, you're talking about immense force.
Absolutely. And the source really emphasizes the use of what they call hard guarding for these mechanical presses, which I guess essentially means these fixed, super strong barriers.
Exactly. No flimsy stuff here.
Right. And they mention a really interesting design element, which is the use of adjustable pin widths in the guards.
Oh, yeah, that's a clever feature.
So what's the purpose of that?
So basically, these adjustable pins allow you to easily change the size of the opening in the guard. So you can accommodate different shapes and thicknesses of the material that's being processed in the press.
Oh, I see. So it's adaptable.
Adaptable and safe.
Yeah.
You need to be able to protect the operator, but also let the material through. It's a balance.
Yeah, it's finding that sweet spot. And it sounds like they also recommend multiple layers of safety for these kinds of high-risk machines.
Oh, absolutely. Redundancy is key. So they talk about things like safety laser scanners, safety light curtains. Some of these light curtains even have what they call floating blanking.
Floating blanking.
Yeah, so imagine a curtain of light. You break the beam, the machine stops.
Right.
Floating blanking allows you to have like these small predefined gaps in that light curtain. So certain parts of the material can pass through without triggering a stop.
That's clever. So it prevents false stops.
Exactly. Improves efficiency without compromising safety.
Smart. And control system upgrades, of course, are also vital to make sure everything's, talking to each other. And then you have the more traditional safety devices like die blocks, power cutoffs, and wedges, which are like physical blocks that prevent the press from activating, usually used during maintenance or setup.
Exactly.
Just in case.
Yeah, just in case. Okay, let's shift gears a bit and talk about something that affects the overall work environment. Noise. The source material mentions sound enclosures.
Yes. That's all about protecting hearing. It is. And it's a legal requirement, right? I mean, OSHA has strict standards for noise exposure.
Oh, yeah. It's taken very seriously. There's a specific standard, OSHA 1910.95, which regulates how much noise workers can be exposed to. And if it goes above 85 decibels, then employers have to take steps to protect their employees' hearing.
And sound enclosures are one of the main ways to do that, to reduce noise at the source.
Exactly. Contain it, control it.
And how are these enclosures typically constructed?
Well, usually they use a framework of T-slotted aluminum, which is lightweight and strong, and then they attach panels made from this dense black plastic called ABS.
Okay.
And what really makes them effective at blocking sound is the use of these specialized dual membrane noise control materials.
Oh, interesting.
Yeah, it's like a sandwich of materials that absorb the sound waves, and then they seal the whole thing up really tight to prevent any noise leakage.
So they're basically creating a quieter zone around the noisy equipment.
That's the goal.
And it looks like you can customize them even further.
Oh, absolutely. You can add things like temperature controls, ventilation, lighting.
Oh, so you can make it, a comfortable environment for someone to work in if they need to.
Exactly. And the source gives some good examples of applications, like enclosing compressors, fans, blowers, generators, test stations, shakers, all kinds of noisy stuff.
Right, all the fun stuff.
Exactly.
Another environmental concern in a lot of industrial settings is dust. And the source talks about dust containment systems as a way to address that.
Yeah, absolutely. It's about keeping the air clean, protecting workers' lungs.
It is. And these systems they're often built as like these large, partially enclosed booths or barrier systems, right?
Right. And they use that same flexible T-slot profile construction that we talked about earlier, with black panels for general containment and then clear polycarbonate panels for visibility.
And I see a connection here to environmental regulations.
Oh, yeah, for sure. These systems play a vital role in meeting EPA air quality standards, specifically under what they call NESHAP specs,
right,
which stands for National Emission Standards for Hazardous Air Pollutants.
Right.
They could even connect you with environmental testing facilities to make sure you're in compliance.
Oh, that's good to know. It's not just about protecting workers, it's about protecting the environment as well.
It's all connected.
It is. Okay. Let's move on to an industry with its own unique set of demands. Food processing. Machine guarding in a food processing environment. I mean, you've got to meet some very strict hygiene standards.
Oh, absolutely. It's a whole different ballgame. You have to think about, food safety, sanitation, as well as worker safety.
Absolutely. And the guarding has to be designed for both wet and dry processing.
Right. It needs to be able to withstand, frequent cleaning and all sorts of different conditions.
And they highlight some of the common equipment and hazards in this industry, like rotating paddle augers, blenders, conveyors, presses.
All stuff that can, if not guarded properly, could lead to serious injury.
Definitely. So what makes these food processing machine guards so special? Like, how are they different from, what you might see in a typical factory setting?
Well, it's all about the materials and the construction. They're typically made from high-grade stainless steel, either 304 or even more corrosion-resistant 316.
Right.
And they need to withstand frequent cleaning, prevent rust. The welds are often what they call 360-degree passivated, which means they're treated to eliminate any tiny crevices where bacteria could grow.
Wow, it's that level of detail.
It is. And they use laser-etched part identification for traceability, special hygienic screws that don't have any exposed threads that could trap food particles. Even the electronic safety devices need to be IP69K rated, which means they can withstand, high-pressure, high-temperature washdowns without failing.
Wow. It's a completely different level of attention to detail. And the source actually shares a pretty significant statistic about injuries in this industry.
Well, yeah, it's quite eye-opening. They point out that 75% of injuries are due to a lack of adequate guarding, which, really underscores how critical these safety measures are. But what's even more striking is that 25% of injuries happen during non-production activities, like startup, cleaning, changeovers, clearing jams, routine maintenance.
So it's not just when the machine is running full speed.
Exactly. It's those in-between times when, people might let their guard down a little bit.
Right.
So safety considerations and proper guarding, they need to be in place even when the machines aren't in their regular operating cycle.
That's a really good point. Okay, let's talk about handling potentially dangerous substances. The source material mentions HAZM containment walls.
Yeah, these are specifically designed for spill containment. They have to meet OSHA 1910.119 standards, which are all about, managing highly hazardous chemicals safely.
So this is serious stuff.
Serious stuff, yeah. You're talking about acids, bases, things that can, if they come into contact with skin or eyes, can cause serious damage.
Absolutely. And so the purpose of these walls is to contain those substances if there's a spill or a leak.
Exactly. Limit the spread, prevent exposure.
And how are they constructed?
So they use modular partition wall sections, usually with stainless steel framing and hardware.
To resist the corrosive effects of the chemicals?
Exactly. And the panels themselves are typically made from black ABS plastic or polycarbonate, which are both, chemically resistant. They form a barrier to prevent those dangerous substances from spreading.
Okay. And then finally, we have fabricated metal machine guards. These are like a more general category for custom design solutions.
Yeah. These are built to print, meaning they're designed for a very specific machine or hazard with, strength and accessibility in mind. You need to be able to maintain them, to operate them safely. So they can be made from strong square steel tubing, formed sheet metal panels of various thicknesses. And the real advantage here is the ability to create very specific guarding, for unique hazards or in very tight spaces where you can't fit a standard guard.
Okay, I see. And they can be finished in different ways as well, right?
Oh, absolutely. You can paint them, powder coat them, the standard safety yellow, or maybe a more subtle gloss black, or even custom colors.
Yeah, company colors.
There's branding, whatever you need.
It's all about, integrating it into the overall look and feel of the facility.
Exactly. And they can be assembled either by welding for, maximum strength or by bolting for easier installation and future modification.
Right, depending on the need.
Exactly. It's all about flexibility. And, they're really designed to provide point of operation guarding for specific hazards. Things like cuts, pinches, crushes, shears, often in those hard to reach areas.
Wow. I mean, we have covered so much ground today, from very basic enclosures to really advanced systems and designs for all sorts of different industries. It's clear that a proactive approach to safety is absolutely essential in any industrial setting.
Absolutely. It's not something you can afford to ignore.
It's not. And as we've seen, it's not just about putting up a barrier. There's so much more to it. There's the engineering, the regulatory requirements, the specific hazards you're trying to protect against. It's a really holistic approach.
And I think that's the key takeaway. It's about prioritizing the safety and well-being of everyone in the workplace.
It is. So for all of you listening out there, think about the different types of guarding that we've talked about today and how they might be used in different industrial environments.
Right. What could you apply to your own workplace?
It's really fascinating when you start to see how much thought goes into protecting people while, still allowing work to get done efficiently.
It is. And it brings up a really interesting point, which is, okay, we have all these physical guards, right? But how do they actually interact with the people using them? How do established work processes, even human behavior, influence how effective they are?
That's a good point.
It's a good reminder that safety isn't just about the equipment. It's about the people, the culture. It's about creating a safety-conscious environment.
That's true. It's a human factor. And if any of you listening out there have any more questions about any of the solutions that we've talked about today, PowerSafe Automation, the source of this information, they encourage you to reach out to them. There's always more to learn, more to explore.
Always. And, when it comes to safety, you can never be too informed.
That's the truth.
That's the truth.
Well, this has been a fascinating deep dive. Thanks for joining us. We'll see you next time.